right, now let's take a look at something new. This is a sector. You can see from the picture that a sector is formed when we take a circle and come from its center, drawing out a radius and a second radius, and then taking this wedge type piece. That's what we call a sector. In order to find the area of a sector, we need to use the area of the whole circle and then figure out how much of the whole circle we have. Like a lot of times people look at that as fractions, like a sixth of it or an eighth of it. But the standard way to do it is to use this central angle. Notice here, this is the central angle. And I'm going to introduce you to a new letter. This is a Greek letter. It's called theta. And it looks like this, kind of a O with a line going through it. That's a Greek letter theta. Let me spell it for you even. T-H-E-T-A. And that's going to equal our central angle. We're going to just use this in our formula. So our formula goes a little like this. The area of that sector is theta, the central angle, divided by 360 degrees, and then multiplied that by pi r squared. So what's going on? Pi r squared is the area of the whole circle, and this is the fractional piece that we want, theta out of 360. So if theta were, say, 60 degrees, we'd be saying, I want 60 degrees out of the 360 by building that fraction. Let's add that to your formula sheet, and then let's clarify it with a few examples. So in each of these pictures, the angle at the center here is theta. And look at this. This is even a sector. We're going to clear around here that kind of Pac-Man looking thing, and that is our theta. And then, of course, the radius is from that center point out, and it would be found here on our circle. So your formula for a sector is to take your central angle, theta, divide it by 360, and then multiply it by pi r squared, the area of the circle. Oh my gosh. I can never do this problem for any class without remembering this funny story. I got to tell it to you. So, oh my gosh, doesn't that look so good? Chocolate cake, delicious. So I'm sitting there, I'm probably about your age because I was in high school when this happened, and my brother comes walking in the kitchen, and my mom had just made a chocolate cake, and it looked gorgeous like this. And he comes walking in, and she's in the other room, and he yells out, "Hey Mom, can I have a piece of cake?" And she says, "Yeah, you can." And so he cuts himself a nice piece of cake, puts it on a plate just like this, and then guys, he proceeds to eat this piece of cake. That is crazy. That's what he ate. So I thought, of course, he was going to eat this one, and we're going to figure out the area of the sector, but it's not this sector we're going to find. We're going to find the area of this sector way up here. Yeah, I just sat there with my jaw dropped. I could not believe he did that. Okay, so let's say this is the cake here. You're looking top view. It's 4 inches. This is about the size of that cake too, because it's 4 inches of radius. And this inner piece right here, this is a 70-degree angle. We are going to find, however, make no doubt about it, the area of the shaded sector. So we need to take our formula. We need to find theta and divide it by 360. And then we're going to just multiply by the area. If we had the whole cake, area is full of the whole thing, pi r squared. So our biggest question here is, what is the theta value? Now theta, again, let me remind you, it's the central angle of your sector, and this is the sector we're doing. So how big is the theta? We're taking out the 70-degree piece out of how much? Well, out of 360. So it's 360 minus the 70 degrees that we're taking out. In other words, it's 290 degrees. That's our central angle, 290 degrees. So that's going to go in our formula. We're going to come up here with 290 out of 360 degrees times the whole area of this, I keep wanting to call it a cake, pi times the radius squared. And pulling from the picture, our radius looks like it's 4 inches. Let's simplify this just a little bit. Call this 16 pi. Let's get the area, 16 pi. Now, let's go to the calculator and calculate out what that's going to be. Let me clear this. So we're taking 290, dividing it by 360, and multiplying that by 16 times pi. Just like that. Check out that display. Do this on your own calculator. You should come up with about 40.5. 40.5 is their approximate value. 40.5 what? We need units. Pull them out of the radius unit there. 40.5 inches. All right, just for fun here, yeah, this part right here reminds me of my brother, this sector. Nom nom nom. All right, in this last example, we're going to have to piece this together to find our shaded area. Let's just put some labelings on here and see what we've got. The lower portion right here in the corner, that's a square. Let's call that part A, and this can be part B, and this can be another part B because they're the same size. So let's just figure out this shaded area by getting our pieces. First, part A. All right, that's a square. So how do we find the area of a square? Area for our square is just the side of it squared. So it's 4 on a side. 4 times 4 is going to be 16 square centimeters for part A. The sector that we've labeled B here, we're going to use our formula of theta over 360 multiplied by pi r squared, and let's see what we can get in there. So how big is our sector's central angle? 90 degrees sound good to you? That's what I'm thinking. 90 degrees out of 360, and then times by pi, and looking back, it's the radius here of 4 centimeters. 4 squared, plug it in. Okay, now I did a little simplifying in the last example. In fact, we had 16 pi before, but I didn't really mess with this fraction because I just didn't want to. I went to the calculator, but I know 90 out of 360. I know that fraction, and I want to make this a lot easier. So I'm going to reduce that. 90 out of 360 is just 1/4 of our circle. I hope you see that. And then reducing, what's 1/4 times 16 pi? A fourth of 16 pi would just be 4 pi. So there's my answer with no calculator necessary unless I want to go into decimal. Now that's the value of the B section, or the B sector I should call it. So the total area is, that's going to be the same thing on this one. The total area would just be to add them all up. Let's total it up and get our answer. Okay, just noting the total is an A section plus 2 of our B sections, those 2 there. So plugging them in, we got for A right here, we got 16. And we got for B, well, bring down that 2. For B, we came up with 4 pi. So simplifying that, 2 times 4 pi is just 8 pi. There's your exact answer, 8 pi square centimeters. If you need to get a decimal for that, let's go check out what it comes out on the calculator as. So 16 plus 8 times pi. And 41.13. Did you get that? 41.13 square centimeters. And both of those look good depending on what your problem wants. All right, so you've got something to do on your own. I will see you in class. In the meantime, I have an appointment with some chocolate cake.